switch off of that and switch back on. All right, there we go. Refresh. Perfect. Got it. Very nice. All right. All right. Hello, hello, hello. Whoa, wow, wow. There we go. Hello, everybody. Okay. Hey, JTS, how are you, my friend? Okay. Not too bad, my dude. Not too bad. Um, yeah, sorry about last time there. Yeah, I guess we have some explaining to do about last time, so yeah, definitely I'll talk about that first before anything else. We had to move back a timeline and stuff, so oh dear. That's fine. If you've been looking through the replays, that's okay, JTS. I understand, life's going to happen. So that's why the replays are just there, just for those situations. Online learning is already tough enough, but to have replays is very helpful. At least you can see anything that you did miss from before. Yeah, no problem. That's exactly what they're there for, my dude. Look, look, certain circumstances call for as many backups as possible. That's just how it has to be. So it shouldn't be, it's not too bad. Nice and relaxed and everything. So I didn't want, this class to be a super burden. Math is a tough subject within itself, but never wanted it to be a very big burden on you. Is homework due this? Yes. Yes, that is correct. Homework is due the same day as the test. And time as well. Hey, Gerda, how are you? Will that be for all homework? Yes. Test date equals homework due date, correct. So when I announce the test date, that's the homework due date. That's right. right? Okay, let's do that. Okay. Good, good. Had to make one change there, but I think it's a good one, so that's okay. Oh, do I still have that? Oh, I do. Okay, good. Woo! Woo! All right. I was worried there for a second. I'm like, oh, I didn't have it. Oh, man. All right. We'll get started here in a couple minutes. We'll just see who else is going to come on in and join us here for today. All right. Hopefully, everybody had a very nice weekend at the very least. Me. Me. Everybody's got a me. A me. uh, all right. It was average. It was meh. It was blah. Yeah, that's right. I did do that. All right. Good, good, good. Good, good, good. Yeah. All right, one more minute, and then we'll get going. Yes, one more minute, and we'll go ahead and get going and talk about a lot of things here today. So we'll discuss that here. Yeah, I'll discuss that in just a second, Gerda. Very valid question, though. Okay. All right, let's get going here. All right. Okay, let's get started today. Welcome back to Tuesday. Hopefully, a nice weekend or a meh weekend at the very least. All right. In any case, all right. In any case, first and foremost here, I wanted to apologize about what happened on Tuesday. Just to give you a heads up, obviously we didn't have really a class on not Tuesday, Thursday, pardon me. We didn't really have a class on last Thursday because my computer went totally bad. Like there was corrupted sectors on Windows and stuff like that, and I had to go get emergency repairs. So, and there's other things that were wrong with it apparently that I wasn't even aware of. So, I got all that fixed up, and by the time it got fixed up, it was Thursday. It actually happened on Wednesday. I was hoping I could get it back before class time on Thursday. Unfortunately, I didn't get it back until like 6:30 on 5:30 6:30 on Thursday. So by that time it was like way too late anyway. By the time I got it back, but the computer is looking nicer now, so it is working as intended. All right, so um, now look, the thing is, I feel I tried to email you guys saying I would do a makeup session on Saturday. I don't know if you guys got that email or not. Nobody really showed up at all. So, yeah, and I didn't know, everybody's kind of busy on the weekends. I know that was a large ask for from me. So, I wasn't like holding my stuff up there. But I didn't want to teach anything on a Saturday since nobody was there. So I was like, okay, that's fair. I'll just delay everything till today. So, I feel legitimately bad because I know you guys, you not only paid for the course, but you make sacrifices for your time to come see, watch the stream and stuff like that. And so, I definitely recognize that, and I feel bad that I wasn't able to do that. I was kind of running like a chicken with its head cut off. I was literally just running all over the place, just trying to get this computer to get fixed. And it did, but I actually lost like 2 days of classes, so it was like, oh man, that's brutal. So it was a big bummer. It was a big bummer. Yeah, unfortunately, it is unavoidable sometimes, but a proper explanation is still necessary, nonetheless. You know, no, I totally get it. Proper explanation still important for you guys. I want to keep as transparent as possible with you guys, in terms of what happened, why did this happen? Why did that happen? All right. Now, what happened on Thursday? Because we didn't have a class on Thursday and because we No, no, look. Like I said, it was a large ask from me. So, it's not your fault for not showing up, okay? It was a big ask from me anyway because we set aside time on Thursday to go do this at this particular time. So there's no blame to go around outside of myself that unfortunately I couldn't get it done on time. But I have made adjustments here to compensate for that time here. So let me go ahead and describe what's going on here. So that way you're kept in the loop. So we didn't meet on Thursday. Nobody came on Saturday. So I was like, okay, what do I do to kind of make that adjustment? So if you've been on Alex, you saw that the test date was moved, and that part is true. So now the test date here, the test and the homework for Unit 3 uh, is now due on the 19th, okay? So, so it's now due on the 19th, all right? So I've adjusted it to next Monday. All right, at midnight is when that homework and that test will be due. Of course, the practice test is put up online so you can get you can get familiar with the questions that could potentially be on that exam. So once again, it's kind of like that. Now, what we'll be doing here today in relation to that is there is one more section that I didn't get a chance to do that has a potential of showing up on this exam, and that is the last section, section 3.7. So technically we're not done yet, but what we're going to do here is kind of what I mentioned last Tuesday, and that was I'm going to go ahead and finish up section 3.7 here, which shouldn't take us too much time, and then I have over here the review for the second test. So the practice test too, we could go over several questions here. I'm not going to do every question, of course, but we could go over several types of questions that you'd like me to go over and get you started with a little bit of a head start for the test that is due next Monday. So that's kind of like what I wanted to do on Thursday, but even if I miss a day, I'll make it up somehow in some form or fashion. And trust me, I always make adjustments as necessary, so it's not too big of a deal. So I gotta live with that. So all right, so that's kind of where we're at right now. Um, are there any questions about that? No? Okay. So I just want to be clear with everybody. I wanted to make it up to you guys, in the best way I knew how, was not to, punish you for something that you have no control over. Okay, that's not very fair. Since you have no control over something like that, it shouldn't be anything that you should be punished for. So I said, you know, I got to compromise here, especially with material that's still there. You know, with material that's still there, you know, I have to acknowledge that fact. So I just wanted to point that out there for you guys. So know that you know, I always look out for the students. You know, I always make sure that you know, you guys get a fair shake at all times. So this is kind of my way of doing that in this case. You gotta do what you gotta do. All right. Okay. So what we're going to do now is we're going to go ahead and start from section 3.7. Now, section 3.7 is going to start from the handout here, and we're going to start on question 11. So question 11 is where we kind of left off last week, okay? So we're going to finish basically just kind of doing the rest of these questions 11 to 15, and then we'll get into the review part for the exam where we can answer questions, or you guys can ask questions about other stuff. So where, okay, where did the book go? Oh, there it is. All right. Put it over there. All right. Thought it was on my chair, and it was not. All right. Okay. So the last section here, which is section 3.7, this is again, the final part here, talks about the concept of variation. All right. So let's answer some questions here, and let's talk about that right now. All right. So what is direct variation? All right. So direct variation is fairly simple. So basically, what you have to look for is you have to look for certain words, okay? So let me go ahead and state what those words are here when we talk about direct variation. So you may see something like this. You may see it as y varies directly as x. So you may see something like that. So y varies directly as x. So if you see something like that, how do we want to set that up? Well, we have this. We have y is equal to k times x. All right, so y is equal to k times x. Now, exactly what is k? K is what we call, in this case, k is going to be referencing the constant of variation. So you'll see this k said time and time again here. All right, so in every single one of these kind of definitions that we'll see. So y equals k times x. All right, now again, we're going to look at some examples here, but you'll see here how we actually employ some of these guys. It's really not as hard as this section is. This section is actually fairly straightforward. All right, let's talk about the next part here. What is direct variation with powers? Okay, so you may see language that look like this. 16, please. Okay, so we could say y varies directly as the square of x. So you may see y varies directly as the square of x, for example. So what does this mean? Well, this basically means at the end of the day that we're going to have y is equal to, actually, bust out that math type stuff. No. So yeah, as you can see, things are a little bit different now. So y equals kx squared. So this is what it means in this particular instance. So y varies directly as a square of x, y equals kx squared. That's essentially how we set up that problem. Whatever y and x are, plug in those numbers or whatever. Okay, next, let's look at this next one here. What is inverse variation? Well, inverse variation, the language that is be associated with inverse variation will look like this. Y varies inversely as x. So you may see y varies inversely as x. Okay, so if you see something like that, how do you set up this variation equation? Well, here's how you set it up. You set it up as y is equal to k over x. Okay, so the k there, as you can see, the constant of variation, it stays in the numerator. It doesn't move. The x, though, does go in the denominator there for that. So that's how we set it up for an inverse variation. Finally, let's talk about joint variation. So what is joint variation? Well, joint variation basically talks about this language. It says, okay, y varies jointly as x and z. So let's say y varies jointly as x and z. So we have three letters here joining the fray. And what exactly does that actually translate to? That actually translates to y is equal to k, so that constant of variation, times x times z. So k times x times z, that is the definition of a joint variation, basically kind of all wrapped up into one sort of expression, just like so. Okay. So that part there, not so hard. Okay, so that's kind of like an information dump there. It says, here you go. Here is some information about that. Okay, fine. Now, having these definitions here will be very beneficial for us. Why? Because in order to solve for variation problems, we just need to plainly use the definition based on what we're given, based on the language that we're given in the problem. So let's talk about a sample problem here, okay? And we'll see exactly how we can solve for that, all right? Okay, so y varies directly as x, okay? If y equals 65 when x equals 5, find y when x equals 12. Okay, so this is what we have here. All right, so y varies directly as x. If y equals 65 when x is 5, find y when x is equal to 12. So what exactly do we have to do in order to solve for y here? Well, let's talk about the key to these problems here. So the key to these problems are fairly straightforward. The key to the problem here is to solve for the variation twice. Okay, so the first pass, you're going to solve for k, and then solve for the letter you want. Okay? Hey, Toast, how are you, my friend? Glad you could make it back. All right, so how are we going to set this up? Okay, so the question is, y varies directly as x, all right? So we're going to use the base definition here of y equals kx, okay? So that's what we're going to be doing here in this case. Now, notice that we're just going to plug in y is equal to 65 when x is equal to 5. So we have 65 here in for y equals k times 5 for x. All right. So here we have just kind of cleaning things up here. It equals 5k. Okay, what should we do next? So what do we do next in order to solve for k? All right, divide 5. All right, sounds like a plan. All right. Okay, And here we got 65 divided by 5. So what's that going to be? All right, 13. Good. So 13 is equal to k. All right, sounds good to me. Now, with this 13 being equal to k, we're going to come back to the same equation here. So we started with y equals kx because y varies directly as x. So what we're going to have is we're going to have y is equal to 13x. And now all we have to do is solve for y. We're given an x here, so we're given that solve for, so basically find y when x is equal to 12. So all we're going to do is plug in 12 in for x into our new equation here. So y equals 13 times 12. All right, and what's our final answer here for this problem? 156, that's correct. Okay, so that's how we effectively do this problem out. Okay, so I just wanted to show the process here about how we would go and do this particular example. So you see we solve for k, then we use the k again in the same equation. We effectively kind of going through this loop 2 times, and then we eventually solve for the letter that we are looking for. All right. All right. Questions about that? Any questions? No? Okay. Yes, you will always solve for k first. That is correct, JTS. So you could take it to the bank that they're not going to give you what k is. You're going to solve for k first with the first given pieces of information. So that's why I wrote out the key there is solve for the variation twice. First you solve for k, then solve for the letter you want. Any other questions before we move forward? Oh, okay. Let's go ahead and move forward then. All right. So let's try the next one here, next example. All right. So I'll write this one down too. So y varies inversely as x. If y is equal to, let's see, y is equal to 12 when x is equal to 5, find y when x is equal to 2. Okay? Okay. So y varies inversely as x. If y is equal to 12 when x is equal to 5, find y when x is equal to 2. All right. Well, this time here, we're going to go ahead and take a gander here. So first things first here. How should I set up this problem based on this wording? How should we set up this problem here? How do we set up this problem here? What's the setup? Y equals k over x. Okay, very good. That's correct. All right, so let's go ahead and put that down. So our first action here is y equals k over x. All right, so that's going to be our template here. Okay. Now, as I said before, we got to solve for k. That's what we got to do. So how do we set up our equation to solve for k? Okay, very good. That's correct. 12 equals k over 5. Right. Perfect. Now all we have to do is solve for k. So we're going to multiply by 5 on both sides. So we can kind of get that out of the way there. Okay, so these 5's, they cancel out. So what's k going to equal here? What's k equal to here? All right, 60. All right, good. Now we're going to take that 60 and we're going to plug it back into the original equation. So here we have y is equal to 60 over x. And now we're just going to use our x value that we're given here. It says find y when x equals 2. So let's do it. So we have this 60 over 2. So what's our final answer here for y? 30. All right. And that's our final answer, 30. That's it. Okay, any questions about that so far? Okay, let's turn it up a notch here. All right. So that's for the second one here. Now we're going to turn it up to 10. So let's do this last example here. All right. So final example here of this chapter. Yeah, there's not a lot of examples to really go around, just because there's very few definitions. So let's go ahead and type this one out. So y, yeah, I'll put that on a new line. Y varies jointly as A and B, and inversely as the square root of C. If y equals 12 when A equals C 3, B equals 2, and C equals 25, find y when A equals 5, B equals 3, and C equals 9. Okay, so here we got a slightly larger problem, okay, in this instance. So we'll back that up a bit. Okay, so this is what we have here. All right. Okay, first things first here. Let's go ahead and set up this problem. But take a look at the definition there. That was the number 14. So we have y varies jointly as a and b and inversely as the square root of c. So here's the joint variation definition, as you can see on the screen. So the question is, how can we put that all together? How is that going to look as a generic equation? Y equals ABK divided by C? Ooh, that's close. Now, I'll definitely agree on at least 4 of those things. So I'm going to put K in the front though. KAB. How about that C part though? C squared? Careful. Look carefully. What does that say? So this one here, yeah, the square root of C. So the square root of c is not c squared. It is exactly as it sounds. It is going to be the square root of c, just like so. Okay. Okay, let's plug in some numbers and let's see what we can get for k. So y is 12, so plug in 12. We don't know what k is, so k is whatever. We have a is 3, b is 2, b is 2, and c is 25, so the square root of 25. All right, let's make this look nicer. So 12 equals 6k over 5. Okay, so we get 6k over 5. Let's go ahead and multiply by 5. Okay, on both sides to start with. So this is going to equal, let's take a look at the next line here. Move this over. All right, so this is going to equal 60, which is equal to 6k. And we'll divide by 6 on both sides. And so finally, we get an answer for k here. K is equal to 10. Okay, so basically once you got the equation set up, it's just a bunch of algebra after that to kind of solve for k. Really isn't too difficult to kind of put it in there. All right, we're not quite done yet, but are there any questions about that? Okay, now let's go ahead and use the same equation here. Is varies directly addition? No, varies directly is multiplication. It's k times x. So I'll put up the definitions here in just a moment, okay, Gerda? You'll have to go ahead and kind of copy those down. So you'll have to know those definitions there. But let me go ahead and finish this problem and then I'll put them up again. All right, so here we have y is equal to, again, KAB divided by the... That's correct. So it varies directly is just one multiplication. Varies jointly is with two multiplications. That's right. Okay, cool. All right, so what numbers are we given here? We are given that A is... So actually, I didn't need to do that. So A is 5, B is 3, and C is 9. Okay, so we have 10. So we have a 10 here. Oops, sorry. 10 is for our K. Then we have A, which is 5. B, which is 3. So that's KAB divided by the square root of C. So the square root of 9. Okay. So we have 10 times 5, which is 50, times 3, which is 150. And then we have the square root of 9, which is 3. So in this case here, we get 50 as our final answer for y. Okay. Any questions? Any questions about that? No. Okay. Okay. Let me put that up for you, Gerda, because you asked. So here's the definitions here. I'll shrink that down. All right, there we go. One more. There we are. All right. If there are no more questions here, let's go ahead and get started with the review here for the exam. So in this case here, let's take a look at the review here. Gonna bring up the practice test here. Practice test number 2. This has 30 questions, but of course not all 30 questions are necessarily on the exam. So we're going to look at different variety type of questions here. All right, just to see what we're kind of working with at the end of the day. All right. Okay. Are there any particular questions you would like me to go over from the review that you'd like me to kind of talk about in particular? Are there any particular questions you'd like me to go over, or do you want me to just kind of randomly choose, or what would you like me to do for this review? Okay, I'm going to start with number 1 there. Okay, that's perfectly fine. We can certainly do that. That's should be just fine. Let me bring up the paint tool then. Okay. All right, so let's take a look at this here. It says a ball is thrown from an initial height of 7 feet with an initial upward velocity of 17 feet per second. Um, can you just go over with one of each? Well, the problem is that it took us quite a long time to do the last one there, and so it's gonna run way too much time for me to go ahead and do each one like we did last time there. Unfortunately, I don't have like the time today to do that. So I was gonna say, like, you pick a random spattering of problems and you get to choose. Again, you can practice with these problems all the time. If you do have other questions about some of the questions on the practice test, you guys can ask me, of course, next class and stuff. So I just don't have like a ton of time to do like all 30. 24, 28, and 30? Okay. We'll see what we could do. I don't want to take up too much time because we do have to do new material regardless. So we can take a few questions. I probably can reserve that time for like after class on Thursday. So um, I think that would be better. But I can take some like in the beginning. So 24, 28, and 30. I'll get to that, Hannah. I'll do number 1 because Fidel asked for that. So yeah, we'll do those 4 at least. So let's go ahead and get started here. So the ball's height h is given by the following. So 7 plus 17t minus 16t squared. Find all values of t which the ball's height is 11 feet, which is 11 feet. All right. So we want to find the ball's height here as 11 feet. So for us to go ahead and do that in this problem, we're going to have h is equal to 11. So we're going to have 11 equals 7 plus 17t, all right, minus 16t squared. So for us here, what we want to do is if we're trying to solve for where it's 11 feet in the air, we're just going to go ahead and subtract. Actually, well, I don't want to subtract, but I guess I could. All right. So here's what I'll do. I'll subtract by 11. I'll have 0 is equal to -4 plus 17t minus 16t squared. Now, to make this easier on myself, what I'm going to do is I'm actually going to take a negative out here. So I'm actually going to like factor out a negative or just take the net, multiply by -1. So if I take out a -1, I'm going to end up with 0 on the left-hand side. I'll get -1 times the quantity positive 16t squared minus 17t plus 4. Okay, so that's what we have here in this particular case. Now, you're probably wondering, why did I do that here? The reason why I did that is because if the coefficient for t squared is positive, it's a lot easier to factor at the end of the day. All right, so if we can get it to factor to nice numbers, it's a lot easier to see if this number right here, this 16, happens to be positive as opposed to being negative. So just trying to boast the laziest and most efficient route. Now this does factor. Again, you could use the quadratic formula to solve for your problem here. You can also use, again, the AC method would probably be useful here as well in some form or capacity. Now, in this particular case, yeah, wait, is that right? I have to look at that again. Let me think. Well, I was thinking it was 4t. So, yeah, you could just do that just as well, JTS. Yeah, that's perfectly fine. You get the same thing. You're not wrong about that. Okay. Well, I thought I knew the factoring here, but I'm not so sure anymore. So I need to make double extra sure that I'm not going crazy. So to be on the safe side, let's do the quadratic formula here for this particular problem. So let's go ahead and put 16t squared minus 17t plus 4. Oh, that. Okay, so we're going to use the quadratic formula here. All right, so the quadratic formula, which is right here. This is our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug in some numbers, and we're going to see what we get. So we have, just to let you know here, a is 16, b is minus 17, and c is equal to 4. So here we get negative b, which is minus 17, okay, plus or minus square root of b squared, so that's negative 17 squared, minus 4 times 16 times 4, and we'll put this all over uh, 2 times positive 16. All right, so there's our quadratic formula. Let's go ahead and clean stuff up and figure out what we're looking at. So we have 17, 17 plus or minus, and we have 17 squared, negative 17 squared minus all that stuff. Let's figure out what that is. Okay, so here I get the square root of 33. All right, so that's what we got there. And this is all over 32. All right. Okay. All right. So this is what we have here. So there's no way we can simplify this down further. 33 doesn't simplify to anything. It's just 11 times 3. So unfortunately, we're out of luck here. So this is essentially our answer for t, are both of these answers here. 17 plus root 33 and 17 minus root 33. Uh, yeah, that should definitely be less than, okay, let's check that. Yeah, all right. So that should be just fine. Okay. Okay. Now, let's see if we put that in here. Okay. I wonder if they'll accept that. I guess not. So let's find out the nearest hundredth is what that asks for. So let's go ahead and take a gander here. So 17 plus the square root of 33. This is just calculator time. Divided by 32. So 0.71 seconds. Uh, oh, or let's see, 17 minus the square root of 33. We'll divide that by 32. Or we get 0.35 seconds. All right, so there we go. We got our answer there, and that's it. Hi, Nitoria. All right, any questions about that? So the quadratic formula will be very helpful for this test. So yes, that's correct. All right, let's continue here. No? Okay, that's okay, Nitoria. Annyeonghaseyo to you too. That's the extent of my Korean, Nitoria. That's as much as I know. Annyeonghaseyo and Kaminasuda. Okay, that's what I learned. That's all I've learned. All right, 24, 28, and 30 were the next ones, so that's on next on the list here. I've been to Korea once. So yeah. One time I've been to Korea. I loved it. I loved it being in Korea. It's really fun. It was a long time ago though. Long time when I went to Seoul. I would love if I were to go back to Korea, then I would love to go visit Jeju Island. I think Jeju Island would be fun to kind of walk around. So this is college algebra. Okay. All right, so this one here. All right, I got you. Solve the following inequality. All right, so we got x plus 2, x minus 4, and x plus 6 is bigger than 0. Okay, so the first thing that we're going to do here in this problem is I'm going to get this guy out. This guy here is going to be our godsend. So the thing is, here we see we got three things. We got x plus 2, x minus 4, x plus 6. And we need to find the roots of each one here. Thanks, Nitoria. Thank you for the follow. So what we want to do is we first are going to find the zeros of this particular polynomial. So can anybody tell me here, what are the zeros of this polynomial? This is already factored out, so we're all good to go. But what are the zeros that we see here? Okay, good. That's right. -2, 4, and -6. All right. Niteria, if you want to ask a question, feel free, okay? You're always welcome in here. Don't be shy. So -2, 4, and -6. All right. So if these are the three zeros of this particular polynomial, this is the thing that we talked about when we chopped up the number line into intervals. Okay, so that's what we're going to be doing here is we're going to chop up this number line here. So we're going to start at -infinity. We'll keep going to +infinity. And then we'll chop up our number line based on the three zeros that we find here. So the first number we'll run into is -6. Then we'll run into -2. Then we'll run into 4. Okay, in numerical order. Now, the next thing that we have to do is, of course, check the inequality. In this case, it happens to be strictly bigger than 0, meaning to say that wherever we see zeros, since it's strictly bigger than, we're going to put parentheses around each one of those zeros. So parentheses automatically around the infinities. But here, as you can see, we actually end up with 4 intervals. So let's go ahead and take a look at each of our intervals here. So we have -infinity to -6, -6 to -2, -2 to 4, and 4 to infinity. We're going to take a test point in each interval, and then we can check to see whether or not it's positive or negative within the actual problem. Okay, so let's take some random test points here in each interval. Remember that the number has to be within each interval. So like in this case, -7 would work. In this case here, we would say -3. Here, maybe 0. Here, maybe 5. So each one of those are proper test points in each one of those particular intervals. And all we need to do is just plug this test point into the original function we see up here and determine whether our answer is positive or negative. So if I plug in -7, do I get a positive answer or do I get a negative answer? So -7. Do we get a positive answer or a negative answer? Negative, that's correct. Okay, how about -3? -3 going to net us a negative answer or positive answer? Positive answer, that's right. How about 0? 0 will net us a negative answer, that's correct. And how about 5? Positive, that's right. Okay, now all we need to do is take a look at the inequality. It says it has to be bigger than 0. So if it has to be bigger than 0, we're going to pick the ones where we got positive results for. i.e. our answer is going to be -6 to -2 and 4 to infinity. So the way we write that is we're going to write, again, well, let me shrink that down so I can read my own solution. So -6 and -2, and we'll union that with a second interval, which will be this. So we're going to have 4 and then infinity. And that's going to be our answer for this problem. Any questions? No? Okay. Okay, now the next one here was 28. Okay, so the next one here we'll do is 28, as that was the next one that Hannah had asked for. So let's do that. Okay, let's take a look at this one here. All right. When a constant force acts upon an object, the acceleration of the object varies inversely with its mass. When a certain constant force acts upon an object with a mass of 4 kilograms, the acceleration of the object is 15 meters per second squared. If the same force acts upon an object whose mass is 30 kilograms, what is this object's acceleration? So this goes back to what we just talked about for uh, variation. Okay, that's where this problem is coming from, is a variation problem. So I could understand, Hannah, why you would have a question about this, since we didn't really talk about it from last time. But now that we have a good idea, oh, real quick question here. The correct intervals depend on the signs according to the inequality. Correct? Uh, yes, that's correct. So if it was less than, I would have picked the negative intervals. So I would, if it was less than, I would have picked these two instead of these two. So that's why we wanted either bigger than or less than 0. That's why we can make that determination, which ones are correct ones. Any other questions about that? Hopefully that's not too bad. I'm going to do this variation problem though. Okay. All right. Now, let's read this problem here once again, and you'll see exactly how we can set it up now that we know the base definitions. Okay. So notice here it says the acceleration of the object varies inversely with its mass. No, that's okay. You're good, buddy. So if the acceleration of the object varies inversely as its mass, how can we set up that variation? How would that look like? So we're gonna have a to b acceleration, and m equals mass. So let's set up the problem here first, just like we did in our examples earlier today. How could we rewrite that? We want acceleration varies inversely with its mass. That's close. Almost. So that would be very directly. That's right. Okay, good job, Planet. That's right. So acceleration equals k, just the constant of variation, divided by m. That would be correct. So it says when a certain constant force acts upon a mass of 4 kilograms, the acceleration is 15 meters per second squared. So in this case here, the acceleration is 15. We don't know what k is just yet, but the mass of the object here we know for a fact is 4. Okay. So what we're going to do here is we're going to go ahead and multiply by 4. We'll multiply by 4. So k here is equal to 60. All right, so k here is equal to 60. Now, with k being equal to 60, now that we are going to repeat this problem here once again. So a here is equal to 60 divided by m. And this time here, the mass of the object is given to us as 30 kilograms. So we have 60 divided by 30. So a here is equal to 2. All right, and that's our answer for this problem. Just using the definitions for variation. Okay, and any questions about that one? We're going to do number 30 next because that was the last one that was asked for. Okay, let's look at number 30 then. Okay, let's look at this one. This one's just a basic setup problem. Write an equation that expresses the following relationship. U varies directly with P and inversely with D. U varies directly with P and inversely with D. How can we set up that particular problem? So directly with P, inversely with D. What do you guys think? Hmm. Okay. Good. I think you bet U there for N, but yeah, same deal. So, good. K times P divided by D. That's it. That's all you got to do. That's all they're asking for in this problem. All right. Good stuff. Okay. Questions about that? That one's not too hard. All right. Let's go grab something here. Go grab another drink. Give me a second. Let me know which question you'd like me to do next. There we go. Alrighty. Okay, which problem would you like me to do next? How do you know what it is when the variables are different? Oh, okay. Really, it matters about the order that they're in. So, like, okay, that's a fair question. So, um, let me go ahead and show you here because these are the notes for what we just did. So the way I know the difference here is U comes first. So basically, if you see it, it's just the ordering that really matters here at the end of the day, Hannah. So basically, U comes first, so that means U is going to equal something. So when you say U varies directly with P, well, yeah, you're going to put it in this exact order. So to kind of highlight that order does matter here in terms of what letters go where. So if you see X varies directly as Y, then X goes here and then Y goes right here. Okay, so I think that's a very valid question here. So I'll go ahead and put that as a note here as well. Note order matters. Okay. So that's if you go into the problem there like just saying, oh, I can just put it anywhere, the answer is no. You follow the definition, order definitely matters. Whatever letter comes first, that's what some letter is going to equal to whatever the relationship is between that and that letter, whether that be direct or inverse or whatever. So that's pretty much how you know which part goes where and based on these definitions. Ooh, tastes like victory. Are there any other questions? Any specific questions you'd like me to do from the practice test? Okay, I'm just going to pick a random question then, and then we'll see where we go from there. Let's pick 10. All right. Okay. Number 10, choose the end behavior of the graph of each polynomial function. Okay, so let's look at this first one. You have x to the fifth plus 3x to the third minus 7x plus 2. Okay, so which one of these four would be the correct answer? Fall to the left, rises to the right, rises to the left, falls to the right. B, rises to the left and rises to the right, or falls left and right. Which one do you think that would be? So if you have notes on n-graph behavior, would be helpful. So notes on n-graph behavior will be very helpful for this because we have to note the degree of the polynomial, okay? The degree of the polynomial in this first case is 5. And we also have to note that the leading coefficient happens to be either positive or negative. In this case, it happens to be positive. So knowing that n-graph behavior little chart that we came up with, the answer here is going to be it'll fall to the left and rise to the right. Okay, for this particular question. Let me look at the next one. Next one, we have a degree 4 polynomial, and we have a negative leading coefficient. So instead of a regular parabola, it might look like an upside down parabola, so it'll fall to the left and fall to the right for that one. Now this last one here is a bit tricky, but the way we figured this out is if you multiply these two things together, whatever it is, we don't really care. Yeah, I can certainly do that, Planet. Ask me whatever question you want. This is a review for you. So if you multiply these together, you'll get x to the third plus blah, blah, blah. So the degree here in this case is 3 with a negative leading coefficient because you have a negative on the outside there. So this would rise to the left and fall to the right. So just the flip, you reflect that. And that's all you have to do for that problem. So this one here is just knowing the graph behavior and behavior of the graphs with our little chart that we had talked about earlier. Okay. Let's go ahead and do number 12 as was asked. Okay, so in this particular case, we're asked to go ahead and do a little bit of long division. All right, so let's go over long division here, and let's see what we get. All right. So this one here, unfortunately, we're going to have to do it by hand. There's not really a shortcut for this one. So let's put this on the outside here. We have negative 2x squared plus 5, and we have 2x cubed minus 7x squared minus 6x to the fourth plus 16. Oh, well, that wasn't very cool of them. All right, got to be careful about that. All right, let me try again. They put this all out of order. All right, I'm kind of mad about that now. All right, let's try this again. Sorry. Okay. They put it way out of order. So no wonder why I was like, oh. Yeah, so just be careful about that. When stuff is out of order, put it back in order. So let me try this again. Okay. So here we have negative 6x to the fourth. We have plus 2x to the third. Plus 7x squared. Okay. Minus 13x. Plus 16. Okay. Okay. So what we're going to do next here is we're going to just try and eliminate stuff out. So what we want to do is we got to figure out how much we have to multiply by negative 2x squared to get, say, negative 6x to the fourth. So the way we do that here is we're going to multiply by, in this case, we're going to multiply by negative 3x squared. So we're going to have negative 3x squared times negative 2x squared plus 5. So let's see what we get here. So we're going to get negative 6x to the 4. We're going to get, oh wait, let me look at that again. Oh, oops, okay. I see what I did wrong. This should be positive 3x squared. That's my bad. All right. Yeah, okay. My bad on that one. I want negative 6x to the fourth. That's what I want. So I want negative 6x to the fourth. This should be positive, right? So, okay. We have 3x squared times 5. 3x squared times 5 is plus 15x squared. So that's going to go here in this column, 15x squared. Again, we're going to flip the signs. So this becomes a plus and this becomes a minus. And so this will cancel out. I'll drop down the 2x to the third, which is what we're after here, at least so far. 7 minus 15x squared is minus 8x squared. And we're going to also bring down the minus 13x here in this case. Okay. Okay, next we want to go ahead and figure out what times negative 2x squared is equal to positive 2x to the third. That's going to be just minus 1x. So that's okay. So we have minus x here, or minus 1x, whichever way you want to put it, times negative 2x squared plus 5. So here we get 2x to the third here. And we get minus x times 5, so minus 5x. Change both of these signs respectively. So now this becomes a minus, and this becomes a plus. So this will cancel out. Leaves me with negative 8x squared. Minus 13 plus 5 is minus 8x. We'll bring down the 16. Okay, and then we just ask again one more time, what times negative 2x squared equals negative 8x squared? Well, that's going to be plus 4. So here we're going to do 4 times 2x negative 2x squared plus 5. So we get negative 8x squared. 4 times 5 is 20. So this changes to, change that to green, change this to a plus. This changes over to a minus. So this cancels out. That leaves us with negative 8x minus 4. And that's as far as we can go, and this is strictly because of the fact that we can't multiply by negative 2x squared to get 8x, okay? So this is our remainder right here. So our final result here is going to be 3x squared minus x plus 4, and then the special way we write the remainder. So then plus, again, negative 8x minus 4 divided by negative 2x squared plus 5. And that will be our final answer for this particular problem. So that's what we're going to put in here for this. So go ahead and move this over. I need to copy this down. So so 3x squared minus x plus 4. Oh, not minus, plus 4, please. Plus 4 plus negative 8x minus 4. Okay. And that will be our final answer for that one. So it is basically, this problem here is just a lot of tedious busy work. So to be perfectly honest. So yeah, that's pretty much how that'll go. Okay, any questions about that one? Yeah, of course. Oh, I forgot. Oh my gosh, I completely forgot. Oh, yeah. Okay, sorry about this, everybody. I forgot to mention a couple of things regarding the test that are kind of important. First of all, there's a time limit of 4 hours for the test, so that should be plenty of time to finish up all the questions. The second thing I would like to actually state is I changed one thing here for this exam that maybe you guys will like. So I changed it up where you no longer have 2 attempts, you have now 3 attempts for this test. So now you get 3 attempts for this test as opposed to 2. So I've just changed it up a little bit by giving you one more attempt if you don't do well the first time, and you don't do so hot the second time. Well, you do have a third try now, where you can actually now go ahead and you kind of start putting 2 and 2 together. So, right. I'm not sure why I forgot about that, but okay. Yeah. I'm sure there'll be nobody complaining about that. I hope so anyway. 3 attempts. So 3 tries is fair. All right. I wanted to make it up to you since we didn't have class last time either, so I thought, 3 attempts. You guys had a little bit of an issue with the last test there, so I'm like, yeah, you know what? 3 attempts seems fair. So I changed it up to reflect that. So no problem. No, you know what? I told you. I told you. It's always a fair compromise in this class. So I'm not going to disenfranchise you. All right? I'm going to give you a fair shake. That's just how it rolls with me. Okay. All right. Let's take a good look here at this problem. All right, let's go ahead and delete all this stuff here. And we'll look at this one. Okay, you have x plus 3 over x minus 4 is bigger than or equal to 0. So in this particular instance, all right, this is going to be a little different than our first one that we did, where we just found this, we found the zeros in that case. Now we're going to find the zeros here in this case as well, but we do have one little exception that we have to take into account. So first of all, the 0 for the numerator here is x is equal to minus 3, and the 0 for the denominator here is going to be x is equal to positive 4. All right, so finding both of those zeros are not too hard to do. All right, I think that's pretty obvious. However, let's take into account what we have to do next. We're still doing the same number line stuff, so we're still chopping up the number line here based on these two numbers, and that's all well and good. So we're going to put negative 3 here and 4. The thing that does change is the brackets and parentheses. Now, any 0 we get in the denominator, okay, which is 4, that's what we got from the denominator, we'll automatically get parentheses there. So we're automatically going to put parentheses here on 4, because that, if we put 4 in the denominator, then that makes that denominator 0, and that's pretty bad. As for the negative 3, the negative 3 here will be a bracket. Now the reason why that will be a bracket is because, as you can see here, we have bigger than or equal to 0. So if we see the equal sign there, that indicates a bracket at that 0. So we're going to put a bracket there, and we'll put a bracket there, and of course parenthesis here for the infinities. So as we see here, the intervals that we have specifically are going to be negative infinity to negative 3, comma minus 3. Put a bracket in parenthesis here. Next is going to be a bracket here, negative 3, comma 4. And finally, 4, comma infinity. All we're going to do is take a test point, and we're now going to do the same thing we did in the previous problem. Just going to do plus or minus. All right, so I'll pick minus 4, I'll pick 0, and I'll pick 5. And we're just going to plug it into the original inequality, see if it's plus or minus. We'll call it a day once we see if it's bigger than 0. So again, the positive ones will be our answers here, or answers. Okay, so negative 4 here is going to net us a positive answer. 0 will net us a negative answer. And 5 will net us a positive answer. So because it's bigger than or equal to 0, our two winners are going to be this guy and this guy. So we get two winners here for the price of one. So our final answer here for this case is going to be, let me shrink that down one more time. It's going to be negative, which one? Oh, this one, okay. So negative infinity to negative 3. And then we'll union that with parenthesis. So 4 to infinity. All right, and that's our final answer. Why is it not bracket 4? Because the 4 here, in this case, Hannah, came from the denominator. So if the 4 comes from the denominator, it's an automatic parenthesis. If we plugged in 4 into the original equation, then that would mean that the denominator would be 0, and we cannot divide by 0. So 4 automatically has to be a parenthesis because of that fact. All right, so that's one of the things about rational inequalities that we have to take into account. Whatever we get in the denominator, that'll be automatically removed. It'll ought to be an automatic parenthesis for anything from the denominator. Numerator, you could get bracket or parenthesis, but denominator, no. Only parentheses for the denominator. For any zeros in the denominator. That's it. All right. Any other questions? Random questions you'd like me to look through? Any other questions, guys? Okay, well, I'll tell you what, guys. Um, I want you to go ahead and take a look at the practice test. If you have any more questions over any of the parts of the practice test, all right, I want you to ask me on Thursday. We'll go over several of those questions, okay? I can do 14, yes. Maybe some of you haven't had a chance to look at it, which is fair. So, but I could do 14 here. Let's do that here. Use the rational zeros theorem to list all the possible rational zeros. Okay, so in this case here, Planet, they're not asking you for the actual zeros. They're asking you for all the possible rational zeros. Okay, so in this particular instance, we need our P and our Q here. So this one I'll just do on the side. So remember, it's the factors of P over the factors of Q. So P here is going to equal, we want the uh, 2. And Q here is going to be that first number that we see here, which is -3. So we want the factors of 2 divided by the factors of 3. So here, factors of 2 are plus or minus 1, plus or minus 2. Factors of 3, plus or minus 1, and plus or minus 3. So all we're going to do now is go ahead and figure out our factors here. I probably should delete that. Go. All right. Now, so this is going to be, again, taking each one of these numbers and dividing by each one of the respective numbers down below. So we're going to get our list of possible zeros here, plus or minus 1, plus or minus 2. That's dividing each one by 1, so it's just the same thing. Then we divide each one by 3, so plus or minus 1/3, and plus or minus 2/3. And that's our answer for this problem, is just that. So we're just going to have, let's go with this, plus or minus 1, comma, plus or minus 2, comma, plus or minus 1/3. And then finally, plus or minus 2/3. And that's going to be our final answer for that. They just want us to list all the possible rational zeros. Questions about that one? Okay. Any other questions before? Any other questions, really? I guess. Any more questions today? You guys can bring more questions on Thursday, so that's fine. Good? Okay. As long as you're good, that's cool. All right. Well, if nobody has any more questions here for today, then this is where we'll end off here for today. We're going to do a few more questions on Thursday because you guys asked, so we're going to do that. All right. In the meantime, take a look at the practice test. If there are any other additional questions you'd like me to go over, we'll talk about it Thursday. We're going to go over a new section, a new chapter here. We're going to start with chapter 4 here also on Thursday as well. Okay? Is everybody okay with that? I hope so, because I got to do it. So, all right, cool. All right. Okay, everybody, this is where we'll end off here for today. I want to thank you all for coming back here today. Thank you so much for understanding. Again, I really do apologize about last Thursday, but that's I'll make sure that we'll try not to have that happen again. Hopefully, the computer is going to stick around for 2 days, so I think it's doing well. All right. All right. Thank you, everybody, once again. Everyone, have a very wonderful afternoon and evening to you. All right. Beautiful weather out there. Get a chance to walk around. All right. I will see you all on Thursday. Okay. All right, everybody. Take care of yourself. All right. Have a great one. We'll see you in 48 hours. All right. See you later, everybody. All right.